Hello friends, today we will going to discuss the SLR concept or the SLR parser, important of parser. So as we know, the SLR is nothing but type of a bottom-up parser. So the parser classification diagram is there. So bottom-up parser contains the LR parser. Under that LR parser, LR0, SLR1, LLR1 and CLR1 is there. So SLR is also called as the simple LR parser. It is same as that of the LR0 parser. The only difference is in the parsing table. So whenever we generate the parsing table, then there are some difference between the SLR and LR parser. So the SLR parser is also called as a simple LR parser and it involves various steps in the SLR parsing. First step is nothing but for the given input stream, it can write the CFG. CFG is nothing but the context-free grammar. Then from that context-free grammar, it will check the ambiguity of the grammar, whether the grammar is ambiguous or not. If the particular grammar having the two equivalent solutions, same solution, then that time that grammar is called as the ambiguous grammar. Third step is nothing but it will add the argument production in the given grammar. Then it will create the canonical collection of the LR0 item, then draw the data flow diagram, and finally it will construct the SLR1 parsing table. So how that SLR1 parsing table is constructed is the main thing. So under this SLR parser, this construction will contain the different types of the steps or the different types of the steps which uses to construct the SLR parser. Under that, the state, if a state I is going to the some other state ij, means there is one state I1 and second one is the I2, that is the I and ij, then that time on the terminal to the shift move in the action part. So I shown into the diagram. This is the one step II and second step is nothing but the ij. So how one element can shift from the one step to the another step is as shown into the diagram, which will contain the state, action and go to. Means there are the two states II and ij. Actions are nothing but it will replace it by the A or the SJ. Second state that is nothing but the SJ and dollar sign and go to with the non-terminal A. So if the state I is going to the some other state ij on the variable, then it corresponds to go to move in the go to the path. So as shown to the diagram, the Ri contains the final item that is nothing but the capital A implies to small p dot, which has no transition to the next state. Then the production is known as a reduced production. For all the terminal x in follow A, write the reduced entry along with their production number. So, for example, SLR parser contain the following grammar, which contains capital S is nothing but the starting symbol with a dot, non-terminal A with a terminal A, and capital A is represented by alpha beta dot. So in this we can follow the S by the dollar sign and follow the A by the small a sign. So like that the table generated for the SLR parser is as shown into the diagram, which contain only one state, that is nothing but the II, and action is nothing but the small a, small b and dollar. The R2 is also one type of the action which is go to the which follow or go to the starting symbol and the A, non-terminal A. For that, the example is shown into the diagram. This example can elaborate the use of a particular SLR parser. So this is the grammar. So first step is nothing but we can add the augment our production and insert the dot symbol in the particular position. So we can add the dot symbol. First we elaborate the starting symbol production and then we add the dot symbol. Then first state is nothing but the add augment production to the I0 state and complete the closure. So we can add the dot and complete the closure. Add the projection to the starting with the E in the I0 state because dot is followed by the non-terminal. So the I0 state is nothing but like this. After that, we can add all productions starting with the T and F, true and false, modified by the I0 state because dot is followed by the non-terminal. So again the I0 state becomes like this. Under this state, I1 is go to the I0 comma E with a closure expression. So what is the I0 comma E closures? It contains the starting symbol with the E dot, E represent to the E dot plus E. Similarly, the I0 with T, F, ID and plus is given. So now we can add all production starting with T and F. Now we concentrate on the T and F and add the dot because the dot is non-terminal and find out the I5 stage. Under that I5, just to we can find out the T and F. Then under next step we can go to the I5, F means we can find out the closure for the T which is represented by F and I5 with the ID means the F which is represented by ID, same as that of the step I3 and I4. After that in I6 we can go to the I2 with a closure with T into dot F, and in this way we can add all the production starting with the F into the I6 step because the dot is followed by the non-terminal. Again the same condition, then I6 contain the T and F representation, then go to the closure of the F, same as the fourth stage, and then we can execute the I7 and I8 state with the go to I5 and I6 step with representing the E and T with the final symbol. So in this way we can represent the particular step under the SLR parser, and finally we can draw the DFA for the particular. So that DFA contain each and every step explanation. So look at I0, I1, I2, I3, I4. This is the I0 step, I2, I3, I4, A7. All that steps are represented by the DFA with a flow from which variable we can go. And this is nothing but the SLR table generated from that which contain the states. Our state is nothing but from I0 to I8. Actions are nothing but the action is performed on the ID plus multiplication and dollar and go to. The flows is go to the E, T and F in this way. So just look the DFA for the SLR example and the SLR table generated for that. You can understand the working of SLR. So this, if you don't understand from the example diagram, then you can understand this example also. This example can elaborate each and every step under the previous slide example. So in this way we study the concept of the SLR parser. Thank you.